This is the current project in my garage right now. This bike belongs to a friend of mine. It's a 1969 Triumph T120 Bonneville 650cc. He just bought it and the engine had been rebuilt. I don't know how long ago, but the engine had a little problem. It was blowing the left spark plug out of the hole. Also, it had a massive leak on the front sprocket right behind here. It was transmission oil just dumping out of it. He wondered if it was an automatic chain oiler, and I said, no, that's not what that is. So we're having to take the primary apart to replace the seal behind the clutch. And we have to pull the clutch out, and there's a plate behind it. You got to pull it out to get to the front sprocket. You got to pull that out to get to the seal that's on the transmission. I can't get a really good view. The transmission shaft comes out of here. There's a space inside underneath this where the front sprocket lives. You can see the chain going into it. And there's a seal on this side and a seal on this side, and the shaft in between them with the sprocket on it. So we're going to replace both of those. So this clutch has got to come off. He's got a puller on order to pull this centerpiece of the clutch out. The head, he ordered a new head to replace this one. This is the head that was in there. I started machining this. The history on this was, you see that black mark right there? The guy that rebuilt this engine had put, I think, a keynsert or a keysert in that thing, which is what you want to use for threaded holes where you're going to be putting something in and out frequently, like spark plug or something else. What that does is you drill it out, you thread the cert in there, and it's got a slot both in the parent, like the head, whatever you're screwing the thing into, and also the cert has got a slot in it, and you drive this square peg down in it and it locks it in place. A helicoil or some of the other things sometimes have a tendency to unwind if you're putting things in and out of it, especially things like an engine part where you're going through large heat cycles where things are expanding and contracting at different rates. Aluminum and steel will expand and contract at different rates. So the nutsert blew out, and then the next repair was they bored this hole out to an M16, put a brass piece down in it, and then threaded the inside of it for an M14.12 or M14 by 1.25 for the spark plug. And the brass, apparently being a very soft metal, it blew the spark plug out again. So this head was trashed. So we ordered a new head, and this is it. And it came with its own little set of problems, and this thing was expensive. First off, this surface right here was not flat. There was a 7/1000 dip in the middle here. We put that on some 320 grit sandpaper with WD-40 on it on a piece of granite, and did the poor man's head machining on it and flattened that thing out. I can't get a 1.5 thousandths feeler gauge underneath it now with the flat bar, so that's flat. The other thing was, this is the exhaust spigot that's on the left-hand cylinder. This is the exhaust spigot that's on the right-hand cylinder. This one didn't have an exhaust spigot in it. It came without one. So we got to looking, and the standard exhaust spigot would just fall out of it. It wouldn't even touch the threads in it. So you can buy these things with a 10/1000th oversize or a 20/1000th oversize. Now the threads that go in here are 1 5/8. That's 1 inch, 625 thousandths. So a 10 inch or 10/1000th oversize would be a 1/635. A 20 thousandths would be a 1/645. When I used the caliper and measured the diameter of the threads on the inside, it was 1 inch, about 644. So the threads, you could see the threads in there, but it looked like they had put a double oversized spigot into it and still stripped the heads out, or stripped the threads out of it. So then they put in this handy dandy little set screw right here. To push it in, it would just loose and then clamp down on this thinking that's going to hold it. Well, it didn't hold it. So anyhow, when the head came in, and I didn't know, I've never worked on any of these things before. I don't know anything about them. So looking at what was going in here and learning about how these spigots go in to attach the exhaust pipes, I pulled a little piece of steel that I had. One of these things. This is, I used to work in the mining industry, and this is what they call a joy gland. This is to run electrical cable through a hole in an explosion-proof enclosure and clamp it. So that's what that is. There's that one, and there's this one. And these, I'm not in the mining industry anymore, so things like this are available to be used. And that's what this was made out of. I turned this thing down on the lathe, and I made the threads in here 1 inch 657, and then threaded it for 20 threads per inch on the lathe. I think that's supposed to be the standard thread size. And it's in here deep. And so I also took and put it on my mill and machined some slots in it across the threads, just across the threads, to make a semi-tap for it. So like the leading 4 or 5 threads that go into it will actually cut their way in. And then the threads behind it that go in, they would fit snugly like a thread forming tool. Now over here, I think I've got an exhaust spigot to show what they look like. Yeah, there's one right there. That is an exhaust spigot. This right here is 1 inch 625, 20 threads per inch. So I machined another piece just like this. It made it 1 inch 657, and I took and cut 3/16 wide slots in the leading threads on it right here. So when I screwed it into this hole, it would cut new threads and then seal. And it's in there real nice and tight. I went ahead and screwed this thing down anyway. I mean, it was there, why not use it? So that fixed this head. So on his old head, what I have done is I have bored this out as big as I think I can get it. And it didn't quite take that key out. But I ordered a 20 millimeter diameter aluminum rod. It's a 6163 or 6063 aluminum. It's T5, it's treated. And I cut the external threads at M20 by 1.5. I drilled this hole right here and tapped it for an M20 by 1.5. The inside of the rod was already 12 millimeter. I ran a 1/2 inch bit through that and then tapped that out for the M14 by 1.25 spark plug hole. So this is going to screw into that. And then once I get it bottomed out, I'll run a 1 inch cutting mill to it with the milling machine. I'll run it down and cut the top of this off and make it flush with the top of the hole. Then I'm going to drill a hole on either side of it at about 98 thousandths. I've got a 100 thousandths diameter aluminum rod. I'm going to pin it on both sides. It'll be a slightly interference fit, but those will be drilled in there. So anyhow, hopefully he'll have both heads, and this one will be fixed. This will be a spare head. I won't be putting that one on. We're going to go ahead and put this one on because it's got valves and everything all fitted up in it. I had to take the valves out of this one to get this on the angle plate. But that's where we are.